Hey guys, welcome back to our YouTube channel. In this video, we'll be continuing on with Pythagoras Theorem. So it is really important that you do understand Pythagoras Theorem and can apply it in 2D shapes as we've been learning the past few videos. Alright, so in this video or lesson, we're going to learn how to identify right angle triangles in 3D solids and further apply Pythagoras Theorem in 3D shapes. Alright, so by the end of the lesson, our goal is for everyone to be able to identify right angle triangles in 3D shapes and be able to apply Pythagoras Theorem in these 3D shapes. So the first thing we need to know, if you cut a solid, right angle triangles can be identified in many 3D solids. So in these shapes here, if you cut that diagonally, you'll be able to see a right angle triangle here. For this square base pyramid, you'll be able to see one here, and for this prism here, you'll be able to see one like that. So once you have identified the right angle triangle, it is really important to draw the identified right angle triangles using a separate diagram, so just like this here. If you don't do this, you'll get very confused, so make sure you're always doing this step. Once we have identified the right angle triangle and drawn the relevant diagram, we can use Pythagoras Theorem to identify an unknown length in the 3D shape. Alright, so let's start off by going through a few different 3D shapes and identifying the right angle triangles in them, just so we can become better at visualizing the different right angle triangles. Alright, so this first shape here, a cylinder, the triangle that is shaded, that is in fact a right angle triangle, so that is one way to find a right angle triangle in a cylinder. We also have that same triangle up here. We draw it like that. So there are these are the two right angle triangles you can use for a cylinder. This cone here, that is also a right angle triangle, so that is the right angle triangle you'll be visualizing and using for your calculations in a cone. This triangle, however, is not a right angle triangle, so Pythagoras Theorem cannot be applied in this case. So if you did want to apply it, just like this cone here, you'll cut it in half and you would have two right angle triangles that you can work with. The cubes here, these are both good representations of right angle triangles. They both have right angles here and here, so they are two examples that you could use for Pythagoras Theorem. This rectangular prism, however, that triangle is not a right angle triangle, so you would not be able to use that triangle. I would use, maybe cut it, sorry about that line, I'll just draw that again. I would cut this rectangle diagonally like that, and now we have two right angles triangle here, or we could do it on that face, doesn't matter, or we could do it through the middle. This triangular prism, that is a right angle triangle, so that is one example that we could use. There's one here, there's also one here and here. This tetrahedron, however, that shape on the base that is shaded, that is not a right angle triangle. That is just a regular triangle, so Pythagoras Theorem cannot be used. If you did want to use Pythagoras Theorem, you could cut down here, and now we have two right angle triangles like that. And this right square base pyramid, that is a right angle triangle, so through the middle, and that is another example that you could use to use Pythagoras Theorem. Alright, so now let's have a go at using Pythagoras Theorem in a 3D shape. So in this question here, the right angle triangle is identified for us, so remember, we always need to draw the diagram for it just so we don't get confused. And it is also very important to show all you're working out. So I've got the right angle triangle drawing here. The base was 8.3 meters and the height is 3.9 meters, as you can see here. And so remember, this longest length is called the hypotenuse. So Pythagoras Theorem says not a squared, sorry. It is c squared, which is the hypotenuse, equals to a squared plus b squared. You guys should all know this very well by now. So c squared equals to 3.9 squared plus 8.3 squared. And it is okay to use your calculator for Pythagoras Theorem. So we have 3.9, just pop that in the calculator, 3.9 squared plus 8.3 squared, and that gives you a value of 84.1. So C equals the square root of 84.1, and once again just pop that in the calculator, and that gives us a value of 9.17. And remember, always check the units. So C is 9.17 meters. Alright, so before we go through this question, just pause the video and have a go yourselves, and just unpause when you're ready to go through it with me. Alright, let's start by reading through the question. A cylinder has diameter 4.4 centimeters and height 6.2 centimeters. So remember, from measurement, diameter of a circle is the full length from one end to the other. So we know that is 4.4 centimeters here. And the height of the cylinder is 6.2 centimeters as depicted in this diagram. So the question asks, find the distance from a point on the circumference of the base, so that point will be here, to a point on the opposite side at the top. So that will mean we have a diagonal line going up here. Give your answer correct to 2 decimal places. This is very important. I forgot to point that out in the question before, but make sure you're doing what the question asks. Alright, so we've got our right angle triangle. Remember to draw the diagram separately. So we have something like that. And the circumference distance was 4.4 centimeters and the height was 6.2. So we use Pythagoras Theorem to find the hypotenuse once again. So that is the longer side of a right angle triangle. So C squared equals A squared plus B squared. C squared therefore equals 4.4 squared plus 6.2 squared. Just pop that into your calculator. I'll do that real quick. You should have gotten a value of 57.8. Forgot the units here, don't forget to write the units. And then C would equal square root 57.8. Once again, pop that in the calculator, and that gives you a value of 7.60 centimeters. Even if it's 0, the question asks you to write 2 decimal places, so make sure you write both of them here. So that would be the length from one point to the other on the cylinder. Alright, this next question is just one of the harder questions in your textbook. I chose it just to go through it with you guys. So just take a minute or two, pause the video here and have a go, and just unpause it when you're ready to go through it with me. Alright, now let's go through this question together. Make sure you guys are actually pausing the video and having a go at them yourself, because that would really help with your learning rather than just watching me go through it. Alright, so the question says the cube in the diagram on the right has 1 centimeter side. So let's start off by writing those in 1 centimeter, 1 centimeter, and 1 centimeter. So find the length of AC as an exact value. So remember, the first step is to always draw the right angle triangle. And also, key point here, the question asks you to find the length as an exact value. If you guys don't remember what that means, just go back to one of the earlier videos. It is in chapter 3a. Alright, so we know that the base of the triangle is 1 centimeter, the height is 1 centimeter, and we just don't know what the longest length or the hypotenuse is. So the formula says C squared equals to A squared plus B squared. Let's start sub them straight in. And we know 1 squared is just 1. So C squared will equal to 2. So C therefore is square root 2. And we keep it like that because the question asks for it in an exact value. Alright, so that's the first half of the question. Let's go to the second half. B. Find the length of A to D correct to 1 decimal place. So A to D is that length here. No, I can't draw lines. It is from here. It's so hard to draw on a laptop. Let's give that one more go. I think you guys get what I mean though. That's a bit better. Yeah, so the right angle triangle will be using A to C and that height. So that is what our right angle triangle will look like. And the right angle is just there. Sorry, it's a bit messy, but the triangle is from A to C here, C to D here, that's the height, and that's the longest point here. So I'll just draw the diagram out. So we have A, C, and D. We know what A to C is because we calculated it in this question. That is square root 2. From C to D, we have the height from the previous information. That is simply 1 centimeter. And we just don't know what A to D is, so we can use Pythagoras theorem to work that out because it is a right angle triangle. Alright, so C squared, longest side, we don't know that, so we'll just keep that as C, is square root 2 squared plus 1 squared. And square root is just the opposite of a square. So squaring a square root means we just get rid of that square root. So it just becomes 2 plus 1 squared, which is 1. And that gives us C squared equals to 3. So C is square root 3. And this time it wants the answer correct to 1 decimal place. Remember, make sure you're always reading this information carefully. So this time we will need a calculator. So square root 3. C therefore equals to 1.7. Always check the units, centimeters. That I didn't add the units here, I would have lost the mark there. Make sure you are always adding the units. So that is, so the length from A to D will be 1.7 centimeters. Alright, so that brings us to the end of this video. You guys should be ready to work on the questions alone now. Just email us or ask us any questions if you have any. And yeah, once again, thank you for watching our video, and we'll see you in the next one.
Boom! 2 plus 2 is 4, minus 1, that's 3, quick maths.